Hello guys. Today's lecture 3. We are in electromagnetism. So today is really important guys. Uh, Electric potential differences, and about the voltage, and we will learn about page voltage and line to line voltage. That's the page system. Let's see. First of all, about the potential, we already, learned when we were student, right? We are student, but like a high school student or middle student. So I will briefly remind you this. If you guys didn't know, it doesn't matter. We will know about it because it's exactly the same meaning, potential and electric potential is exactly same concept. So let's see. Potential energy is the stored energy in any object by some its position. For example, this is now ground, right? But now it's moved here, right? On the closet. So from the ground to move here. So it has now potential energy. If it's, we say this is a point and it has a potential energy. So we need to learn about also this concept. 1 joule is the amount of work done when an object moves 1 meter due to a force of 1 Newton. So which means, as you can see, this is the equation. So this has a, energy. We need to we use this energy to move this. So we say it's joule. Newton is just some force and meter is distance. Now it's high, but it also could be distance, right? So let's see more. So electric potential is exactly same concept. What I said is work is done by moving a charge particle from the infinity to the other point. You know what I mean? So which means, okay, let's move. I'll explain more, okay? Look at that, guys. So for example, this is on, okay, a point, okay? Here's gravity, and box in it to a point, okay? Yeah. Differences is only this time is charge, right? But this is box. So about the infinity, we say this is the ground, right? We need the reference point, right? So we in electricity, we say there's a 0 point. You know what I mean? 0 electric point reference point. Okay. So we say this is Earth. That's we make it the Earth is to the ground. You know what I mean? So as you guys can remember the Coulomb's law here, look at that, which means that between the charges, the distance, right? Between the charges, there's a power, right? But I will, ask you guys. I wanna, okay, Q1, and this is Earth. There's also Q1. Just 1 Coulomb here, okay? It's Earth. So first of all, could we move this box to the A point? There's gravity, right? So the box itself could to A point itself move? Of course not, right? Also, this is the same because look at that. Here's charge, right? There's some power, right? But now it's plus, right? If it's a cross, repulsive happened. So it cannot move itself to the, we say, okay, just here's A point, here's B point, here's C point. Okay. So it cannot move a ABC point by itself, right? So it needs external energy, right? The external energy, I said, it could be heat, it could be wind, it could be physical, energy. For example, this box, I will use my hand, my physics, you know what I mean, to move this box. So whatever, the external energy is, it doesn't matter, regardless about the external energy. Now, the 8-point box has a potential energy, right? We ignore the external energy itself. It makes it just a potential, right? This context is the same. So there's many external energies, right? Like it could be heat, it could be wind, something, or a chemical. By the way, the external energy to help them to move a point. The thing is, so now it has a potential energy, but specifically it has a electric potential energy. So we say voltage is potential energy. That's why we say voltage is a potential energy. But many of you guys may still confused what is the voltage or current. So since you guys and me also, while I'm studying, I also I always thinking, I mean, when I prepare to teach you guys, I also remind me. Sometimes I know, abstractly, that exactly. So, I also need to learn exactly. That's why I explained to you guys, right? So we need to make sure, like if I just abstractly know, which means we don't know, we need to explain what is that exactly. Okay, so that's why both of us we could learn from this lecture. Let's move on. Oh, sorry, and I didn't explain about it a little bit. So what I mean is the box, when you move the box from the A point to it needed we spent energy, right? Sure, right? Because we see 1 joule is a 1 return, right? This is the distance. This is some energy, right? To move the stuff, some force, right? So it's equal to, right? So the potential is, actually the unit is. We also moved something, right? We could say joule. And we move the charge, right? The coulomb. The unit is coulomb. So it's voltage. Yeah, that's it. Let's move on. And yeah, this is also important. So we already know about the voltage, right? From the reference point, the Earth, okay? And the only difference is now there's two charges. Between them, they ask, look at that. This is Earth. This is charge. Between them, they ask, okay? Let's see more. Okay. So okay, look at that. Here is the Earth, the 0 point. Here, voltage A, voltage B. The voltage differences they asked is this, okay, between A and B. So soon I will talk about why we need to learn about math, okay? And since the current and voltage, it's we could explain it in magnitude angle. So we need to learn about pager. So the pagers, to run the pager, we need to, learn how to explain it. For example, here, look at that. This is 1, this is 2, same. A, this is B. B, A, V, A, B. Do you know what the difference is? Look at that. It's a rule, okay? To learn about the page, you guys have to memorize. So when it, 1 or 2 pager indicate, start from where we need to go, the destination. B, right? And A, here, right? And here, look at that. From, where we need to go. V, A, right? Where, from where? B. Okay? This is, the basic concepts to, step by step, we will learn about all the pager. So let's look at, this is a Y wiring, and this is a neutral. Don't worry about it. You guys even don't know the neutral thing right now. I'll explain later, okay? So this is A, B, C, okay? For example, this is 0 point neutral is I said we need the reference point, right? 0 potential point, right? So here it is. So between here, this is phase. Here, it should be here. Let's see. Let's have a question to revise. Look at that. But what about if it's this and this? It's line, right? Sorry about my drawing skill. So for example, if I want to go here to line, it's from where? Now we need to first write down the destination, right? C, B. Yeah, we see B here, okay? For example, here we need to go to the we need to get to the A, right? A from C. That's it. That's right. And look at that. I will, let's see. Because why we need to learn about the concept, basis, accumulate. Maybe you guys still don't know the delta and Y. What's the differences? And why when it delta, the same voltage but different current. But why? Okay, same voltage here. But here current is same. But here different is a current. Same is here is here different is current, but here is same is current. Difference is voltage. We need to learn why. Who always just memorize when it have a test. Look at that. It's easy. So here, for example, 1, the length, okay? 1, the length is 1, okay? But we know the page, right? Here it's neutral, right? So if it's a 1, the page is, this is line to line, right? It's a more longer, right? That's why we say there's a root 3 times the line voltage root 3 times is bigger than this when voltage when the Y wiring. But instead the current is the same. For example, this delta page and line is the same. That's why we say voltage is the same. But why we current is different? That's why we need to run. Look at that. I'm kind of digressed from the main point, but I want to show you guys why we need to learn some important laws and why we need to memorize. Look at that. We need to learn about the Kirchhoff's law. Look at that. This is, I will say, line current, okay? And A, B, C. So current I, A, B, I, B, C, I, C, A, right? So look at that. The current flows here, here, here. Kirchhoff's 법칙, Kirchhoff's law says, look at that. Here is zero, but this one current here and these two is same. You know what I mean? From here to these two, same. So here's zero, which means look at that. So we can say I, L equal I, A, B, no, I, L plus I, A, B equal ICA. You can see, look at that. The current is flows here, for example. So it comes out to here, right? So look at that. The current 2 years here, it's I line and IAB, make it ICA, right? So same. So let's more. Look at that. So ICA and I line IAB ICA, right? ICAB minus ICA, no, sorry. ICA by ICA minus IAB I9, right? So I'll explain why the delta, when the delta, the line current is root 3 times or bigger than the phase line. Look at that. So look at that. That's why we need to also learn the Kirchhoff's laws and the page. It's really important to draw this. That's why we learned. Look at that. So we have a three lines, right? IAB, IBC, ICA, right? So I will say just 1, 2, 3, okay? 1, 2, 3, right? But ILAN is ICA is number 3, right? From here, but minus IAB, right? AB is here, right? Minus is totally 180 degrees differences, right? Same, but which means I could say I C A plus minus I A B는 equal I line, right? So that's why move to here. 1, 1, page is I current is root 3 times more bigger. That's why we make it this. Okay, guys. Okay, let's go back to the main, point. We almost done. Don't worry about it. So look at that. So why we need to learn math? Because I said by the way, there's only two things we need to calculate and control: voltage and current. Whatever power is also voltage and current is, it's including. So look at that. So we could interpret them in page because it has a magnitude and angle. Magnitude is, you get this arrow, Angle is the theta, huh? Right? So every angle, it has a different value. That's why we make it sine or cosine, right? That's it. Look at that. So to get the, the triangles, R is magnitude, theta is angle. To get to this, we need to learn about rectangular form and polar form. That's it, today's lecture. I hope so you guys can understand everything. Thanks a lot, guys.